new staff member to MailCore and gonna try to go over some of my Docker workflows with you today and kind of hopefully you take some of this and you reinvent it. I'm not by any means a Docker expert or somebody you should you know look to for Docker advice, but uh, I'm certainly someone that can you can bounce ideas off of, and we can definitely talk. So if you get some curiosity or you want to talk about this stuff later, then by all means feel free to ping me or just send me a personal DM. So we can kind of talk about what Docker is first and kind of get into the specifics of Docker itself so that you have an understanding of what it is and then what you can use it for. I also have this available on a Git book, which I'll be sharing afterwards, so that you don't really have to write the notes down. It's all just right there for you. You can just get into it right after this if you want to. So Docker itself kind of enables development teams to create bite-sized applications. In a way, it will kind of allow you to create smaller pieces of your application so that you don't really have to worry about performance issues, some scaling issues, and even with Docker you can hook it into Kubernetes, and Kubernetes can kind of scale it for you in a way, with some configurations, of course. One of the major advantages of Docker versus the traditional VM is that VMs kind of are heavy by nature. So when you spin up a VM and you have something like Ubuntu on it, you're getting a lot of like the desktop features, you're getting a lot of like underlying things that you would need to run a physical computer. With containers you don't kind of get that. You get more of what you would need to keep your application going. It's kind of more catered towards Linux-based operating system type things, because Windows doesn't really run too well on containers as far as I know, but to each their own. I'm not saying that it's impossible, I'm just saying it's probably tougher. So with that, containers themselves, what are they? Like I said, they are kind of more of a lightweight version of a VM. The technical breakdown is they let you stand up applications and all the necessary dependencies in a isolated environment. So in theory, you could have a bunch of containers running on like a normal desktop, and then just have have the desktop in a server room somewhere, and then after that you can kind of just keep spinning things up, keep tearing things down, trying new things, and even some of what we'll do today is hooking into containers, and we will basically be kind of creating those applications on the fly. Yeah, and then like I said, the less technical answers, they're just lighter weight VMs. They instantiate a lot quicker than a traditional VM, so they're a lot easier to play around with. Sorry if it sounds like I have a bias towards containers, it's because I do. So where do you kind of get, the things to build a container? How do you get this going? So I'll be honest with you, installing Docker on Windows is kind of tough. Even right now, in this moment, I'm still trying to get Docker working on this VM. And if I have to, I'll probably just do it on my personal desktop so that we can just kind of get this going. So when you create a container, what it needs is kind of like a blueprint or a set of instructions on how to kind of instantiate. So with that, you can use something that's kind of called it's an image. So it is something that you could pull down to kind of tell the host or tell the Docker engine to kind of take this set of instructions and build you your specified environment. This is kind of so that if you are on a development team and you all need to work in the same type of environment, but you have different types of computers, you know that by doing this in Docker, it will always work across your development team, because essentially the Docker environment is the same across your development team. So they don't need to worry about if they're on a Mac. They don't need to worry about if they're on Windows or if they're using VS Code versus Visual Studio. As long as the Docker environment is the same for everybody, it should theoretically just work across the board. So the other thing is too is you can take these pre-installed images from what is called the Docker Hub, and this is the default registry for these images. So you might think of this as something like the GitHub for Docker. It is kind of the same thing, but there are some differences. So you can still take a bunch of images and upload them to essentially your Docker registry and then pull them down at will. Um, it works kind of the same way, but with some nuances. They, like I said, they kind of work like regular Git servers. You can theoretically pull something down like Artifactory, and you could self-host your own registry so that you could do things like image scanning, so that you're not downloading malicious images, and you're a little more protected in that aspect. It's the same way that you can self-host like your own Git server. The kind of main point to using Docker versus traditional VMs is that they kind of provide you that isolation, the efficiency, and the portability. In a normal enterprise environment or a production environment, companies will use this to bite-size their application and spin out different pieces of it so that it can do things like load balancing. If the application starts failing for one specific user, you can have that container die out and be replaced with a new container, so that if they refresh the page, they're working with a new container and something that is working for them, and that you don't really have to worry about that user experience kind of degradation. But today we are going to kind of explore the unorthodox uses of Docker. We're going to build process flows. We're going to do things that I specifically do with Docker, and then I'm hoping that you guys can kind of re-engineer that and readapt that, and then after that, hopefully you kind of share that with me, and then we can kind of expand on the unordinary uses of Docker. So some of the things that we'll be kind of going over today is creating your own development environments. How can we hook in VS Code to a container and start developing on the fly, so that we don't have to download things like Python, Golang, .NET, Node.js all onto our host PC and then bloat our host PC with things that we don't need later. We can just spin up a quick environment for all of those things and then tear it down right afterwards. We can even do things like what I'm going to call double sandboxing, only because we will be working with Malcore and creating calls to Malcore. So we'll be sandboxing inside the container, and then when you send it to Malcore, Malcore will also sandbox it. So that's where the double sandboxing comes from. It's a little out of scope, so I'm not going to go into the actual like POC or demoing of it, but how you can do things like use containers to perform red team operations or pen testing. So you can do things like download files through the container and then use a mounted volume to kind of push those to the host OS, so that things like smart screen won't trigger on it, and then you can remove the mark of the web, so that it doesn't flag for administrative privileges or things like that. And then of course we'll kind of close it out with blueprinting a Docker file and kind of what it means to build your own application so that you can use it later. So let's get into it. Let's see if Docker wants to work for me on Windows real quick. It does not. All right, we'll do this on mine. Give me 2 seconds, and I will get this going for you guys. I guess now would be a good time to queue for questions. Does anybody have anything in specific they want to talk about? Kind of what I've gone over.
To stop them, there are different Docker restart status flags that you can specify for how you want a container to operate.
Okay, yeah. So let me see if I can start running some commands here. I'm going to have to switch through screens, so you're going to have to bear with me because I don't want to self-dox, and because I'm doing this all on my host. So I think kind of what you mean is like with containers, they can be ephemeral, so you can kind of like spin them up, tear them down, and have them kind of do their tasks and then be torn down afterwards. Or kind of what I'm thinking is like if you have that image in your Docker hub, then you can easily pull it down to new infrastructure and spin up a whole Docker, I guess, swarm of things that tasks to complete, vulnerability scans to. What we'll do here is I already have Docker installed, so it's kind of out of scope for me to do things like a Docker installation within this. You can kind of learn on your own. I'm sorry if that's kind of cold, but it's kind of a unique situation for everybody. So it's not really. I could walk you through it, like I said, if you want to message me later or something like that. But it's not really a one size fits all thing. Um, it's unique to your operating system, and that's kind of where Docker falls off. So what we'll do here is we will actually build a new container. So what I do a lot is I rebuild Python environments, and then from there I'll push my code and everything like that. So we can, this may be where I start doing some of the unorthodox things that normal Docker users don't do. So what you should theoretically do is, use Docker image to pull down the image that you want to work with. What I do is I just want to get it running, so I just kind of start with that. So with that, you can use the Docker run command. It will pull it down and then also start the container for you. One of the things that I like to do is I like to keep the container kind of running and then also running in the background, so that if I'm using it as a development environment, I can keep developing and I don't have to worry about the container dying out on me. And then some of the other things you'll see me do is open up some ports for it to run, because optimally if I'm running something like a Flask application, which is something we'll be doing in a little bit, you kind of want those ports to be open, because that's kind of how you'll get internet to the box, more or less. So I'll run some flags here and I'll kind of talk through what I'm doing. So the D flag here is for detached mode. As far as I understand from detached mode is that it kind of runs it in kind of like its own instance. You don't have to really worry about it completing a task. You don't have to worry about it running everything in your terminal. It just kind of does it in the background on its own. The IT flag, I'm going to look these up so I'm not leading people astray, because I feel like I just naturally run these. But we'll keep going. So I'll circle back to that so that we're not spinning. What I'll do here is I'll also name the box. This is for organizational purposes, so that you don't have a bunch of things that are just like weird names. Like if you spin up a container, it might spin up as the tag name, or it might spin up as like a bunch of numbers, weird stuff. So good practice, let's name our box. So we'll just call this one Python with Malcore. Again, that's what I'm going to be doing. I'm going to be opening up ports. As far as I know, Flask runs on port 3000. So right here, what you see me doing is kind of, this might be the other way around, but the 3000 here will represent the port inside the container, and then what we're going to do is forward that with a semicolon to the host, which will run on the same port. And then this is where we start specifying kind of our image. So if you write Python here, it'll pull down Python, everything you need, and it'll just kind of keep going. The problems that we're facing here is what we want to do is not lightweight anymore. So if we pull down just Python, it'll pull down kind of the latest version of Python, and what is up there right now will be probably like a 400 megabyte image, which is kind of a more compact version of what we'll actually get, which is probably going to be closer to something like 800 megabytes. And that's just too much for what we need to do. So what I usually do is I use the tag slim, and then I use slim buster because it's Debian, and that's what I'm comfortable with. Again, reinterpretation after this, feel free to do what you want to do. We'll run that, and then you'll kind of see it do some weird things where it might pull down the image, and it might do some what is called layering, where it will pull down the different layers of the image and start running those commands. I believe I already have this, so it may just do I think it's the hash. Yeah, whatever this is. So this is now running in the background. Um, and you can kind of see that here, I think, with this extension. Yeah, so there it is right there. So you can see here, I wasn't lying, that's what I do. This specific container is for something I'm working on now, and then I use this Golang container to learn more about Golang and develop Golang in there. Um, don't have Python or Golang on my host operating system at all, which is kind of nice because then also my operating system on my host OS runs a little bit better, so that if I want to play games or something, I'm not, again, bloating it with things like Python, Golang, .NET, things like that. So then there's where you see the name as well, and then those crazy wacky letters are your uh, container ID. So we can actually do attach Visual Studio Code here, and what it'll do is it'll actually hook in our Visual Studio Code instance inside of the container. Um, now is the part for kind of disclosures. Uh, Containers kind of run kind of at the value that you set for them. So if you've set a bad security configuration for your containers, these are going to be very vulnerable containers, okay? So images come with vulnerabilities. These are running on normal operating systems, like I said earlier. This is running on Debian. There's instances of Debian that have vulnerabilities. So you want to look into things like securing containers or securing Docker endpoints so that you don't have somebody that can abuse your container and then hook into your operating system and things of that nature. So if you're spinning these up, just be conscious of security things. I say that, and then this container is going to be running as root. So that's not really in the scope of this. So I don't really want to, secure a container in front of you guys and kind of waste your time with what the theory of what all this is supposed to mean. Um, so you just kind of want to develop these techniques on your own. Stay conscious of, you know, this is kind of where your DevSecOps understandings come in. So you know that if you're spinning up a container, you need to secure it. Maybe there's a script you run beforehand. You have it pull down, and then when it pulls that down, it locks everything down for you. That would be probably most optimal, in my opinion. So we've hooked into this container. You can kind of see what I was working on last time. I don't think that's true to this container. I don't think there's actually things within here that are, yeah, you'll see that path does not exist. Okay. I'm going to start also apologizing. My dog doesn't like it when I hop on a video. So you guys might start hearing my dog start to bark in the background. Okay, so how do we know that we're in the container? You can see down here, it says actually editing on container Python Slim Cluster. That kind of comes with the Docker extension for VS Code. As far as I know, that's the easiest way to do it. I think there's a way to do it with dev containers, hooking into remote systems. You can do this the same way with like a remote server. So if you have a server that's running in Linode or on-prem or something like that, you could do it the same way. Um, in my documentation, I'll link to a video as well on how to do that. So I already have something that's, I see there she is. So I already have something that's running, kind of up and running. So I should have kind of gone with that. Let's see. So that's how to start the container. We'll switch over containers here. And then VS Code's going to yell at me because that container died out. So we'll switch to the running one. And then here I'm going to pause real quick because I'm pretty sure this is a dev instance, so I don't want to, self-docs again. I've probably got some API tokens sitting in here, so just give me 2 seconds to clean this up, and then I will do some presentation on what this is doing, and kind of, hopefully you can take some ideas on how to develop your own stuff. Token?
Yeah, man. Just give us all your tokens. I think everybody here wants your API token.
Especially mine. I think I have the dev one going right now.
Oh, yeah, don't do that. No, never mind. Okay,
Oh,
everybody's
that's
good.
awkward.
Admin sees the consequences of his own actions
Oh,
approach in real
oh,
time.
Dang, karma hit me quick, didn't
oh,
it?
that's weird. Okay, let's see.
All right, back on track.
We're back over here. Okay. So, let's see. Closing out other instances so I'm not confusing myself. Okay. I was a good boy. I secured this beforehand. So kind of what this is doing is, I've started with the API call for malcore domains, and you can kind of throw things right there and toss them into your payload. Send it like normal Python. I'm not going to teach you the Python request library, but when you kind of pull this down, you can start iterating through some of the documentation that it provides you. Like if it's saying that it found a bunch of IPs related to that domain, you can spit them all out here. What I was specifically doing with this is I was taking this and pushing it to a front end with Flask. It was a little messy. It still needs things like Bootstrap to kind of clean up the information, and then as well as if you dump the domain into this, you're going to get a lot of information back. So you got to do a little bit of your data flow and understanding kind of what you want back and how much is too much. And then from there you can develop stronger tools and use that information across different things. Like, you might pull in other data like gray noise and see if this is, an APT that's scanning for credentials or looking for a specific vulnerability. You can keep expanding on that, and that's what's kind of cool about hooking VS Code into Docker containers. You can keep developing with this, and it can be something that you push to a repo and you make private so that people aren't pulling down your dev stuff. But you can spin this up at like a coffee shop and you can start working on this there. That's what I do a lot. You can spin this up in let's say that you're doing some kind of recovery for a client or something like that. You need a tool that will get you the information fast, so you can pair that with your Malcore API and kind of pull down that information fast, so you don't have to go through the regular user interface flow where you have to like log into Malcore and pull run the domain scan and everything like that. This way you can pull all your data down and kind of, again, on the fly, portability, scalability. You can keep developing this tool too, which is cool. So all that kind of to ramble and say keep coding. And don't let my silly little weak Python app be like what you have to do with this. You can take that data and you can say, okay, what does my infrastructure look like? If I have a domain that's running vuln scans for clients and stuff like that, did it get popped? Am I on abuse IP? Kind of thing like that. So that's where your reinterpretation comes in. You have to make your own tools and entertain your curiosity. So the next thing I kind of wanted to go over is kind of like that was both a mix of hooking in VS Code to a container and also Malcore sandboxing. I'm not going to run this because I'm pretty sure it does take a while to run, and it does take get a lot of information back, and it is still something I'm developing, so that you'll see that I'm still developing it, and that, again, out of scope for this presentation. So where you can kind of take Malcore into this is if you're examining something, let's say for a client, and they have something on their host OS that you need to examine real quick, and you don't really want to throw that onto a new forensic PC. You don't want to have to, grab a USB, throw it onto your examination PC. You can kind of create something that will mount the volume from the host OS, and then you can just drag those things into a folder and have it automatically run something within the container that shoots it out to Malcore and then gives you back kind of like an executive presentation, so that if you have your CTO is coming to you and it's like, hey, I clicked the email. what is this? Like, I need a quick summary of what I just clicked on or something like that. You can just quickly throw it into a container, toss it into that container, have something that outputs something like a PDF or an XML, maybe some JSON, just a quick report so that you can tell somebody like exactly what they have. And that's kind of where the sandboxing part comes in, is it pushes it into the container so that it's not executing anything. You don't have to really worry about it. It can kind of delete itself afterwards too if you want to. So it just kind of uh, gets out of the host OS and pushes back into a controlled environment. Another thing that you can kind of do is that these containers, if there's not proper monitoring set up for some kind of engagement that you're doing, containers are really hard to see into visibility wise. So not only are you trying to monitor your host OS, but that means that you would have to monitor everything underneath it in terms of like a hypervisor, in terms of like, you know, again, the Docker engine running and what it's spinning up and what's running inside of those containers and things like that. So with that, a lot of companies don't have that monitoring. And with that, you can, you know, start running things inside of containers. Like, let's say that you need to run a kind of a little more of a stealthy Nmap scan. You can do that with a container, and it'll look like it's coming from the host operating system. And you know, an inexperienced blue teamer might look at the host operating system and see what processes are running on there, and they might not catch all that stuff running, you know, kind of at a deeper level and stuff like that. So they might just like, you know, pass it off and just be like, okay, it might just be like Microsoft updates running. It's nothing weird, or they're just sending emails back and forth. So it kind of looks different network traffic wise, kind of what you're doing inside of those containers. So that's where that mark of the web kind of comes in. You can download all your tools to the containers. Nobody's going to probably see you download Mimikatz and push it to the host OS and normal container breakout stuff. Let's see if we can get it to blueprinting a Docker file now. So that's something that that's something we can do together, and kind of close out the presentation, and then we can kind of talk about what you guys can do after this and kind of how you can reinterpret it so that you don't get kind of stun locked by imposter syndrome and things of that nature. So let's say that I want to get this running. Okay, so some of the things that I will need are, to start is the Docker file. So firstly, what you saw me run earlier when I ran the Docker run command is you saw me pull down the image. So that's something that you need to specify at the beginning of your Docker image so that Docker kind of knows what to pre-install, and then from there you can kind of have it do other things before you get to the container at a user perspective. So we start by specifying the from statement and saying Python. This is pretty much the exact same thing as what I did where you pulled down the image. It's just when you run the whole Docker file, this will kind of work in the background. Again, a best practice is to not really do the latest, otherwise you will get whatever was last pushed to that Docker registry. So we will do the Slim Buster because that's what we knew we were working with. And then you can start doing other things, like we know that we need things like Flask and things like the request library for Python. We know that I think it kind of comes pre-installed with Python, but I don't know if you saw it. I had the git pass library in there, so we might need that. So now we can start kind of driving Docker. So we can say, okay, now I want you to use the pip command, and then from there run these commands. So in a perfect world, we would have a requirements.txt file, and we would have that kind of installed at the beginning. So I think that would work. So it's going to use pip, and it's going to install all of our necessary libraries and stuff like that. As a dev, you're going to be doing these things naturally and kind of making sure that you have something that'll kind of point to your dependencies so that we don't have to guess kind of what you need and build that out. So, we have things like the request library, we have the Flask and everything like that. Another thing that we need to do is we need to expose those ports again. So with that, it's quite literally the expose command, and then you can do, I think this works as well. I'll have a reference to how to write Docker files from Docker themselves. Um, I believe that's right. I could be wrong. I haven't written a Docker file in quite a while because I kind of, like I said, just run it from a dev environment perspective. I don't do a lot of creating my own applications yet, but that's something that I'm working on. Probably right after this, actually, is creating that Flask threat hunting tool. So, if you're curious after this, feel free to reach out because I probably will be working on it. So we're exposing those ports now. Some other things that we might need to do is we might need to update, like Debian itself. So we might need, if we have dependencies that we need to run, or we tell it to run a specific file, or another thing you can do is, let's say that you already have your stuff built out and your Git repository initiated, and you really don't want to just have to copy and paste that into a new container or anything like that. So you can use the copy command, and your first thing will kind of be your host OS folder. So if I say like right here, it'll copy everything within the current working folder. So I believe this is working at the home level, so it will copy everything that's in the home folder. And then you kind of want to specify where you want that in the container. So we said that we were working out of the home folder, and we can just put that into a new Linux. We can put that into a new project. So we can just say code and then Flask app, and then that'll kind of work. This is a very, very immature Docker file. I've seen some that are like at least 50 lines long. There's a lot more you can do with this. Like I said, you can start running things like scripts that will automatically secure the container for you so that you don't have to worry about doing that every single time. Optimally, you want to put this into an automated workflow. Maybe you have something that you want to test automatically, and you have the same kind of similar test conditions that you work with. So with that, you can throw what you have into that Docker container, have it run all that, and then again spit out something that's kind of a report on how it did and stuff like that. That's actually what a lot of DevOps teams will do, is they'll kind of run things through quick Docker environments to kind of see if it will work within their next configuration or production and stuff like that.
Not to interrupt, but it's probably worth mentioning you can add environment variables to Docker
You can.
containers.
Yes, you can. So let me pull up my Docker file thing so that I'm not missing anything, because I'm doing this all by memory. But this is kind of where you can start, configuring those environments. Kind of what the admin was saying is that you can add environment variables. So if you have like a .env folder, you can push all those variables into the Docker instance and stuff like that. Let's see here. I totally got off track of where it was. Docker file. Okay, so there we go. Yeah, you do that with literally the the env command. So then you can say something like API equals something like that. You can also do user. I believe user lets you add users. And then I know I've been talking a lot about it too, but you can do, it would optimally go here because you're creating the volumes before you're copying things into them. But then you can do, like if I was working out of a Linux environment, then I can do...
Well, we the same people?
Huh? You good? So, if I have a host volume, I can essentially mount that. I can, or not a volume, a directory. I can have that kind of directly linked with a directory inside of the Docker container. So if I put something into my host operating system directory, it will automatically be pushed into the Docker container, and vice versa. It will be, kind of pushed backwards to the host operating system, and that's kind of where you need to start worrying about, securing the containers, because that is, I'm not saying that itself is a vulnerability, but that can lead to vulnerabilities. So yeah, with that, you can literally take that, and I believe, I don't have the extension installed within the container, but you can literally right-click this and have it just run, and Docker will automatically just create the container for you. That being said, too, you do need to run the container. So if I say, I believe if I say Docker run here, it will actually try to look for a Docker file and build that. So I believe that works. You can look into it. This is hopefully entertaining some curiosity, so you get into Docker yourself and you kind of learn the nuances of what you can do. This is kind of, you can think of this as unorthodox in the way that this is not the normal uses for Docker. So optimally, like I was saying, development environment or development teams will use this to kind of bite-size their applications so that they don't have to restart whole VMs if a service goes down. They just have to restart the small little bit container, and then everything's just working again, and it just naturally hooks back in together, and then you don't have to worry about rebooting a whole VM, which we know is literally like rebooting a whole actual physical machine. So you can kind of think of this as re-engineering things like a Jenkins server, or like Puppet, or things that you would normally use for like DevOps operations or traditional development environments. And I think that's kind of where people lock themselves into kind of a way of thinking, because you don't really need to stick to the orthodox ways of Docker to use Docker. I think that's kind of what Docker pushes to, is that they push the portability and the scalability and all of that. They don't necessarily say that you have to use this for development environments and pushing your new product and everything like that. So in the documentation that I'm going to give you guys later, I will hook in a link to 7 ways to escape a container, and it's more from a pen testing perspective, but it kind of gives you an idea of how somebody can abuse a container. And I don't think that's something that's really surface level knowledge in cybersecurity. I don't think there's a lot of people that understand containers, let alone cloud itself. So, and then kind of some closing statements is, kind of some things I thought about that you might consider is, how can I scale this? So something that I think about all the time when I'm making applications is kind of the forward thought of how it is going to look in the future. So if you have something like an application that is, really small like mine, and it's that like little Flask thing that kind of just returns back API call information, that's not really something that you have to worry about scaling immediately. But if you have something like, for instance, Malcore, wasn't originally such a large product, but as it grew, it needed newer things, it needed newer features, and even with sandboxing, maybe they don't want to sandbox that within a virtual or within a bigger server. Maybe they just want to do it quickly on like a container, get it done with, and then shut it down and return back the information. Um, that's that's kind of what containers are traditionally used for, and you can do things like I'm not particularly a fan of it, nor am I really keen on how to use it. You can use things like Docker Swarm to kind of spin up big instances and kind of I'm not sure if it does it, but like maybe load balance some things and hook in some other services like SQL databases or I don't know like some like Node.js or things like that. You can do that with also Kubernetes. This is where the bias comes in. I think Kubernetes can kind of do it better because Kubernetes kind of makes it user-friendly for you. It does the load balancing, it does the scaling, it allows you to have kind of more or less failover with things like replica sets and all that type of stuff. So yeah, Kubernetes is also again out of scale or out of scope for this presentation, but that's also something that I encourage you to look into as well, as it can make you stronger and with your applications and stuff like that. And then how to kind of get this into an automated flow. So a lot of things we've talked about is how to create your own Docker files or how to create development environments and things like that. Those are the kind of things you're going to use for your Docker flow. So if, let's say that I'm starting up a pen test and I'm using a new IP on like DigitalOcean or like a Linode VPS or something like that, I might have a script that automatically runs that installs Docker, pulls down the images I need, and kind of gets me ready to start. That's where your Docker images can kind of be pulled down from Docker Hub or from GitHub, or maybe you have a private Git server that's exposed at your house from your home lab. You can push that out that way too. And then from there, you're just ready to go. It's not a matter of running terminal commands for an hour trying to get all your stuff working. It just works. That's the great thing about Docker. It sounds like I have a bias, and it is because I have a bias. I didn't learn Docker the orthodox way. This is how I've learned Docker, is by using it the unorthodox way. One of the first things I learned was how to hook VS Code into these containers, and I already see a difference in terms of like working with other people who have the programming languages on their PCs. That being said, there are some nuances to it. Like you may need certain network configurations to be to be able to push to things like GitHub or something like that, or like certs and stuff like that. Like I said, they're not technically really within the network. They're in the network, but not within the network. So that's where you start getting some of those like SSL errors or things like that, which is not common for somebody that's just doing this at home, but it might be common for someone that's doing this in like an enterprise environment. And yeah, so that's about it. I will get a link out to the Git book on kind of what we've talked about, what you can do, and yeah. Is there any closing questions? It felt like a long-winded ramble, and I feel like Charlie Day with that meme talking about all the different things you can do with Docker.
Awesome. Thanks, man. That was insightful
Yeah.
and a lot of information. Does anybody have any questions? Anybody want to add to what was said or anything?
Bueller.
All right. Sounds good. Well, I appreciate everybody coming out. Thank you so much for all the information. All that good stuff, man.
I'm more than happy to link with people on this. I think we have an engineering channel in here too. So if you kind of want to go over stuff in there, and then, like I said, I'll drop the Git book and learning resources. And then I'm also going to do a little disclosure statement. The Git book that I'm linking is not fully fleshed out. So what I have written today is fleshed out, but everything else is kind of a skeleton. So
cool. Sounds good.
Cool.
I will say one of the one of the things that the reason why I about the restart parameters and whatnot being passed as variables because that is one of our most favorite features. Being able to have a container, on a schedule where it can be shut down and re-executed from a security perspective. How much of what you hear of in terms of typical persistence efforts could have been in theory broken with a simple restart, and yet
Mm-hmm.
enterprise environments don't always get daily restarts. You can see in our channel, all of our shit gets restarted every day, and it all just springs back to life. That's something that's so neat about Docker because they're like little, micro environments per se. It's super quick to actually take them down and bring them back up to test changes and stuff.
I've heard of them referenced as kind of like a Mr. Meeksies. They're little things that just kind of do the task and then die out afterwards.
So like that's in theory, yeah, that's a way to use it, but that's also a personal usage. Like
Yeah, it's more of
Sentry
a use
runs in
case.
Docker, entire Discord bot on Docker, and it's
Malcore's API runs entirely in Docker too.
I had a feeling.
you can set like restart flags and whatnot so that it enables, if you in theory have something that's already self-contained and it can start up and run on its own, you set that restart flag. Now your restart frequency can be whatever the slowest thing on that box is.
Mm-hmm.
uh, there's a reason that in work and in enterprise, there's a meme of did the end user actually restart their computer? Because you'd be surprised how many people can't restart a computer.
I
Yeah,
mean,
Docker is amazing. Everybody loves Docker.
even you could write a tool yourself that can kind of monitor containers or even other containers, so that if something does happen, I mean, Portainer kind of is somewhat like
Also,
that without
Grafana,
monitoring.
you would probably, in theory, if you had something running in that container, you would bind a Grafana agent to it and then use
Mm-hmm.
that for stat reporting. So in theory, you get an outage report if no stats.
Or like a sidecar or something like that.
Yep, yep. All right, guys. Cool. Appreciate it.
Yeah, no problem.
Send me the recording, please. And
Yeah.
Jay, I'll probably send it to you for other like